Today we're going to start talking about three-dimensional figures, and section 11.1 was nets, space figures, cross-sections, and Euler's theorem. So let's start with some vocabulary. The first word is a polyhedron. It's very important because a polyhedron is a solid that's bonded by polygons. So not all three-dimensional shapes are polyhedrons. For instance, a cone has the shape of a circle as a base, okay? And a circle is not a polygon. So a cone is not a polyhedron, a sphere is not a polyhedron, and lastly, a cylinder is not a polyhedron because their faces are not all polygons. But polyhedrons do have faces, edges, vertex, and we're going to talk specifically about the bases. Bases are these sides. This is what we technically think of. They're the polygons that bound the polyhedron. We typically see triangles, rectangles, and squares as these sides. Those are the basic ones, but we will see hexagons, octagons, pentagons as the bases. The edges of a polyhedron are the line segments where the faces meet. So wherever the two faces meet, then you have an edge. A vertex is a point where three or more edges meet. So if you take a look, we have a line, a point, and technically this is a plane. So we're using all those vocabulary words from chapter 1 to form these three-dimensional figures. Lastly, we're going to talk about the base. The base is really important. It's a part of the polyhedron, but it's really how we name it. Because if you have one base, it is a pyramid. If you have two bases, it's a prism. So we're going to talk more specifically about how to name it by identifying the bases. So when you name a polyhedron, it really has a first and a last name. The first word is always the shape of the base, and the second, or what I like to tell you is the last name, is the number of bases. So it's either going to be a pyramid or a prism, depending on if it has one or two bases. So for instance, if I tell you number 1, the base of this, we'll just mark this, and it's a square. Okay, so the first word would be a square, and then we look at how many. If there's only one, then it will be a square prism. I'm sorry, a square pyramid. I listed that wrong. Okay, so this would be 1 and this means 2. So the formal name for this polyhedron is a square pyramid. You have to have those and you can't just call that a pyramid. So looking at number 2, if you notice, we see 1, 2, 3, 4, 5 different rectangles. So since there's 5, those are not the bases. Because remember, you can only have 1 or 2. So our base, or bases in this polyhedron, are the 2 pentagons. So the first word would be the pentagonal. And then the last word, the last name, would be how many there are. And this time there are 2. So the formal name for this is a pentagonal prism. So let's take a look at this shape, this polyhedron, and I want you to pause and see if you can count how many faces, edges, vertices, and then name it. All right, so let's take a look. Hopefully you found the faces. Remember, you can include the bases. There's 1, 2, and then each rectangle, 3, 4, 5, 6, 7, I missed one somewhere. Oh, the front, 8. Okay, so that's how we got 8. Don't forget to include the bases on your faces. The edges are just simply these segments here, and don't forget to go all around the bottom, okay, or the top. These are all edges that I'm tracing out right now. Okay, so you should have gotten 18 of those. Lastly, the vertices are the corners or the points. So you should have 12 different points, or 12 different vertices that you've counted. Now, remember, we have the shape of the base, which is a hexagon, so we call that a hexagonal, and there's 2 of them, prism. So hopefully you did well on that one. This is a formula called Eulers Formula. The formula is listed up here. You have to memorize this, and really it's just a shortcut on how you can count. If you have any 2 of the 3, you can plug it into this formula. F stands for faces, V stands for vertices or vertex, and E stands for edges. Okay? So if we look at number 1, they give us the edges and they give us the vertices. So plugging that into the formula, Euler's formula, we should have x plus 20, because we're trying to find the faces, equals the edges 30 plus 2, and we're going to solve that for x. And that actually tells us that there are 12 different faces on this polyhedron that is shown. You can't see them all, but there are 12. So go ahead and try the second one on your own. And here is the answers for, this is the equation, and you should have gotten that there are 30 edges on this polyhedron, and we're going to get to these in a little bit, and they actually name these specific ones. All right, let's talk about nets. You should have seen nets before, and really it is a way that we can take a three-dimensional figure and lay it flat out on a piece of paper so we can see all of the surfaces. So that's really important because we can see what it's created, what it's made out of, and then you can fold it back up and it would create your polyhedron. So this net is actually the square pyramid net, okay? Because here's the base. Anytime you have a star-looking net, this will be your base in the middle. So just figure out the shape and it will be a pyramid. So let's take a look at some more nets. The net of a cube, just think about it like a cardboard box and you're like uncutting it, unwrapping it, and laying it flat. So see if you can draw what the net of a cube looks like. Here is what it could look like. What you do need to remember is a cube has square faces, and there are 6 of them. So this looks like a T, and there's 6 squares. That's the net of a cube. What about this? It tells us it's a pentagonal pyramid. Okay, even though you can't see the whole base, so see if you can draw the net of a pentagonal pyramid. And remember, anytime you have a pyramid, it's going to be a star with your base in the middle, and then you always have triangles attached to each edge. Okay, so that's what the pentagonal pyramid net looks like. And we're going to go ahead and match the top to the bottom, which is which. Okay, see if you can drag and match which ones. Here are the right answers. Okay, now the cone is not a polyhedron, but it still does have a net because you have to form it somehow. And sometimes you will see the net have a circle on the bottom, because really if it's without the circle, that means it doesn't have a base, that base, but that is what it actually looks like. So those are those nets. All right, a cross section, this definition, is the intersection of a solid and a plane. So it's, imagine that you would take something and take this plane and slice right through it. You would cut right through it, almost like if you were opening up an orange or slicing an orange in half. Then the cross section of an orange would be a circle, because that is the two-dimensional part that you cut through. So right there, the cross section is a triangle. So whatever 2D shape is what is formed inside is your cross section. So that's just a visual thing to see. So let's take a look at these 5 really important types of shapes. I said we'd come back to it. We've already talked about these 2, or not talked, we've seen when we did Euler's formula. These are called the Platonic solids, and they're named after the Greek philosopher and mathematician Plato. Now, why are they so important? It's because they are made up of regular shapes. Remember, regular is all sides and all angles. They're all the same. So we'll have angular and equilateral triangles that make up the tetrahedron. You have squares that make up the hexahedron. Likewise, you have, with the triangles, you have equilateral, triangles equilateral, and on here you have pentagons that are regular pentagons that make this up, okay? Now, what you do need to know from this is you need to know all 5 names. You need to know how many faces each one has. And there's a way to determine that, because these all come from a Greek or Latin root word, and we will look at their nets and how they're formed right now. So the tetrahedron has 4 different triangles that are created from it when you fold it up. So tetra means the word 4, and it has each side is an equilateral triangle. So really what you need to take away is 4 equilateral triangles form a tetrahedron. A hexahedron, or we also call this a cube, but its formal name is hexahedron. But hexa actually means 1, 2, 3, 4, 5, 6. Okay, because there are 6 squares that fold up to make a hexahedron. The octahedron is formed by equilateral triangles, and there's 1, 2, 3, 4, 5, 6, 7, 8. So octa means 8. You probably remember that or know that. Octagon, 8-sided figure. Okay, and that's how that would fold up and look. The dodeca, kind of like a dodecahedron. If you take a look, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So dodeca means 12. Each side is a pentagon, and there's 12 of them that would fold up to look like the dodecahedron. Lastly is the icosahedron, which looks crazy with all these triangles, but if we count it, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So icosahedron is a 20-sided, isosa means 20, or 20 equilateral triangles. If you would fold that all up, you get the icosahedron. What you really need to take away from this lesson is really how to name a polyhedron with the bases.